By the end of this video, you should be able to calculate the pH of the reaction mixture at various stages of a weak acid versus strong base titration. Let us say we are titrating a 25 milliliters of 0.100 molar acetic acid solution with 0.100 molar sodium hydroxide solution from the burette. Again, to simplify things, we will break down the titration curve into 4 different stages. Stage 1 is before the titrant has been added. So, in the beaker, we have 25 milliliters of 0.1 molar acetic acid solution. How do we calculate the pH of 0.1 molar acetic acid solution? Pause the video here and answer the question. Weak acids such as acetic acid dissociate partially in water. The dissociation is governed by its acid dissociation constant Ka. The hydronium ion concentration at equilibrium can be calculated by setting up an ice chart and equilibrium constant expression as discussed before. Solving for hydronium ion, we get 1.34 times 10 to the negative 3 molar. Therefore, the pH is negative log of hydronium ion concentration, which comes out to be 2.87. Now let us move on to stage 2, that is before the equivalence point. The equivalence point we calculated earlier is at 25.00 milliliters of sodium hydroxide. So we can pick any volume of NaOH before the 25 milliliter mark. I picked 12.5 milliliters of sodium hydroxide, that is halfway through equivalence point. After 12.50 milliliters of 0.1 molar NaOH is added to the 25 milliliter of acetic acid, what is the pH of the resulting solution? Pause the video here and answer the question. Acetic acid reacts with hydroxide ion to form acetate ion and water. The K value for this reaction is greater than 1. Since the K value is large, it is a limiting reagent type problem. We will do the dilutions first, then set up an ice chart and calculate the equilibrium concentrations of all species. At the end of the reaction, we are left with acetic acid, which is a weak acid, and acetate ion, which is its conjugate base. We can calculate the pH of such a solution by Henderson and Hasselbalch equation. pH is equal to pKa plus log of weak base concentration over weak acid concentration in the solution. Substituting the values of the concentration of weak base, weak acid, and the pKa values, we get pH is equal to 4.75. We can take any volume of sodium hydroxide from 0.1 ml up until the equivalence point. The calculation will be similar. In the next slide, we will see what will be the pH at the equivalence point, that is in stage 3. Stage 3, at the equivalence point, 25.00 ml of 0.1 molar sodium hydroxide is now added to 25 milliliters of 0.1 molar acetic acid solution. What is the pH of the resulting solution? Pause the video here and try to answer the question. Let me write down the equation again. Acetic acid reacts with hydroxide ion to form acetate ion and water with K value greater than 1. We will do the dilution first, and set up an ice chart and calculate the equilibrium concentrations of all species. At the end of the reaction, we are left with acetate ion, which is the conjugate base of acetic acid. Acetate ion can react with water and change its pH according to the following equation. The OH- ion at equilibrium generated by acetate ion can be calculated by setting up another ice chart and solving for X. We can then calculate the pOH of the solution and followed by pH. The pH comes out to be 8.72. The pH at the equivalence point of any weak acid strong base titration will always be greater than 7. The reason for this is, at the equivalence point, all the weak acid is converted into its conjugate base. Therefore, the solution's pH is greater than 7. Stage 4. After the equivalence point, we can pick any volume of sodium hydroxide after the 25.00 ml mark. I pick 37.5 ml for this example. 37.5 ml of 0.1 molar sodium hydroxide is now added to 25 milliliter of 0.1 molar acetic acid solution. What would be the pH of resulting solution? Pause the video here and answer the question. Let me write down the equation again. Acetic acid reacts with hydroxide ion to form acetate ion and water. The K value for this reaction is greater than 1. We will do the dilutions first and set up an ice chart and calculate the equilibrium concentrations of all species. At the end of the reaction, all the acetic acid is consumed and we are left with acetate ion, which is the conjugate base of acetic acid and the OH- ion. When a weak base and a strong base is present in the solution, the pOH of the solution is solely determined by the strong base. Because the OH- generated by a weak base is negligible compared to the OH- generated by a strong base. Therefore, at equilibrium, we have 0.02 molar hydroxide ion, and we can calculate the pOH of this solution. pOH is equal to negative logarithm of OH-, which comes out to be 1.70. And the pH will be 12.30. This is how we calculate the pH of the reaction mixture for a weak acid versus strong base titrations at different stages of the titration.